Hey, Stats Kids. Today we're starting chapter 4, section 1. And today we actually get to start doing some real statistics. We spent chapters 1, 2, and 3 kind of looking at all of the background information we need to help us get into the idea of what is statistics. And chapter 4, we really start getting into the meat of it. So buckle in, notes out, and here we go. All right, the first real statistic thing we're going to look at are discrete probability distributions. And that sounds really fancy. We're going to break that down kind of word by word as we go through here. The first idea we're going to talk about is a random variable. A random variable is exactly what it sounds like. It's a random variable x. And that's going to represent a numerical value associated with each outcome by probability distribution. So x is just x, like we've been thinking about in algebra, algebra 1, algebra 2. X is still x. Don't need it by x. But there's two types of variables we can use, discrete or continuous, and that's what we're going to talk about. For example, x could be the number of sales calls a person makes in one day. So they make 10, 50, 100 sales calls. It could be the number of hours spent on sales calls in one day. But there's two types of variables we can use. One is a discrete random variable. A discrete random variable has a finite or countable number of possible outcomes that can be listed. The point on that one is can't be a decimal. All right, so finite means it can't go on. Sorry, what does finite mean? Finite means countable. Discrete means it's got to be integers. So for example, x equals the number of sales calls a salesperson makes in one day. So a person can make 0 phone calls, 1 phone call, 2 phone calls, 3. What the person cannot do is make 2.5 phone calls. You can't make a half phone call. That doesn't count. Either you do make a phone call or you don't. Therefore, that variable would be discrete. The variable being the number of phone calls, that's discrete. Has to be an integer, can't be a decimal. The other option is a continuous random variable. A continuous random variable has an uncountable number of possible outcomes represented by an interval on the number line. This one can be a decimal or fraction. For example, the number of hours spent on sales call. Well, you could spend 1.5 hours. You could spend 1 1/4 hours. You could spend 3.25896 hours on a sales call. So that, because those can be decimals, that turns it into a continuous random variable. So if it can just be integers, no decimals, fractions, it's discrete. If it can be fractions, decimals, then it's continuous. So let's look at some examples of that. Decide whether variable x is discrete or continuous. X is the number of Fortune 500 companies that lost money in the previous year. Well, if x is the number of companies, can you have half of a company? Does that make sense to say you have half of a company? And hopefully in your brain that's telling you no, either you have a company or you don't have a company. Therefore, that one has to be discrete. Number 2, x is the volume of gasoline in a 21-gallon tank. Well, you could have 5 gallons, 10 gallons, but can you have decimal gallons? So 1.2, 1.5. Yes, you can. So this one is continuous. Go to the next page. Go ahead and pause the video for a moment and answer number 1 and number 2. Determine whether the random variable x is discrete or continuous. Number 1, let x represent the speed of a rocket. Well, a rocket could go any speed. It could go 100 miles an hour. It could go 100.5 miles an hour. So it can be any number. So therefore, it is continuous. Why? Because it can be any number. That's the explain your reasoning part. Number 2, let x represent the number of calves born on a farm. So baby cows. Can you have half of a baby cow born? That doesn't really make any sense. So either you have a cow born or you don't have a cow born. And so that is discrete, right? Can only be integers, right? No fractions or decimals. Any of those explanations would work. All right, now let's move on to the next step. Now that we know what a discrete variable is, can only be integers, we're going to look at a discrete probability distribution. We looked at distributions back in chapter 2. Then we added in the probability component. Now we're going to combine those together to be discrete probability distributions. So we've talked about all of this in some sense, but now we're kind of merging all of this stuff together. A discrete probability distribution lists each possible value of the random variable can assume together with its probability, must satisfy the following conditions, right? All probability has to fit between 1, which always happens, and 0, which is never happens. So all probability has to be between 0 and 1. We're going to use that as a check later on. And also each probability, if we add up all of the events, has to equal 1. Because if we take everything that could possibly happen, add up all of their probabilities, their decimals, we have to get 1 because one of those has to happen. Otherwise, we're not taking something into account. So to construct a discrete probability distribution, we're going to let x be a discrete, right? It has to be an integer, random variable with positive outcomes, whatever they are. We're going to make a frequency distribution. We've already done that. Find the sum of the frequencies. We've already done that. Find the probability of each possible outcome. That's our relative frequencies. And then find each probabilities between 0 and 1, and the sum is 1. That's our check step. So let's see how that's going to work. Example 2, we're going to construct a discrete probability distribution. An industrial psychologist administered a personality inventory test for passive aggressive traits to 150 employees. Passive aggressive is you're like nice to people, but you're like nice to people in a mean way. Individuals are given a score of 1 to 5, where 1 was extremely passive, 5 was extremely aggressive. A score of 3 indicated neither trait. Construct a probability distribution for the random variable x, then graph the distribution using a histogram. So here we have a table. And the score is what you got on the psychologist test from 1 to 5. And then he recorded the frequencies of how many people scored that number. And that's going to be our random variable x. So x, actually I lied, x is going to be these numbers. So x can be a score of 1, 2, 3, 4, or 5. So there's our discrete random variable. What we're going to find, and in fact it said that right there, there's our x, is we want to find the probability. So we want to find p of x. And to do that, we're just going to add up all the scores. So 24 plus 33 plus 42 plus 30 plus 21, that gives us our total. That's our n. That is 150. Then we can go back and find our probability of x was just our frequency divided by n. So we're going to take all these numbers, divide by 150. So get your calculator, see if you can beat me and do this. So this gives us 0.16, 0.22, 0.28, 0.20, 0.14. These all came out to 2 decimal places. Usually we'll go to 3 decimal places, but these just happen to come out to 2 decimal places. So there's our probability. Now to make our distribution, we're going to just make a nice little distribution graph. So here's our p of x, our probabilities. The biggest our probabilities get are about 0.30. So I'm just going to go by 5s. So 0, there's 5, there's 0.10, there's 15, there's 0.20, there is 0.25 and 0.30. And I'll come back and fill those in. And this is our table. This is P of X for personality traits, for passive aggressive, for a title. And then we have our scores. So at the bottom, we'll go our scores, and I kind of lost some room down there. So that's scores, and our scores were 1, 2, 3, 4, and 5. Apologize, I ran out of room there. Didn't have much room. And then we're going to just make a bar graph. But again, these are going to be attached bars because these are all together. So for 0.16, that's just above 15. So there's our 0.16, and we have a 0.22 for 2. We have a 0.28 for 3. We have a 0.20 for 4, and we have a 0.14 for 5. So there is our probability distribution. Now you'll know from previous lessons that looks like a symmetric uniform distribution. And so that's something to talk about. We've talked about that before. And so did we answer our questions? We graphed the distribution using the histogram. So that graph was our answer. Try yourself 2 on page 102. A company tracks the number of sales new employees make each day during a 100-day probationary period. The results for one new employee are shown at the left. Construct a graph a probability distribution. So we're gonna do the same thing. In fact, if you want to go ahead and pause your video, try and come up with your own distribution and see if we get correct. So the first thing we need to do is find n. So if we find up sum of n, all right, so we sum up all the f's, all the frequencies, we're going to get 100. And we know that it had to be 100 because there was a 100-day probationary period. And therefore, now we can find our percentages. So we're going to take all of our, so our P of X, again, that's our frequency over N. Well, these are all just divided by hundreds. So we just moved the decimal point 2 places. That's 0.16, 0.19, 0.15, 0.21, 0.09, 0.10, 0.08, 0.02. Now we want to make a probability distribution. And I ran out of room, so I'm going to turn my paper here to the side to make my distribution. And so here we need a title. So percent of sales per day. And so on the left-hand side is our P of X, and that's going to go from, what's our biggest? About 0.20 was our biggest. So I'm just going to go by 0.05s. So there's 0.05, 0.10, 0.15, 0.20. And then on the bottom, there's our x's. So our x's start at 0. We're going 1, 2, 3, 4, 5, 6, and 7. And then we're going to make our bar charts. And again, our bars are connecting. So 0 is 0.16. 1 is 0.19. 2 is 0.15. 3 is 0.21. 4 is 0.09, 5 is 0.10, 6 is 0.08, 7 is 0.02. So again, there's our frequency distribution for our discrete probability distribution. A lot of fancy words there. Still making a bar graph. Next part, example 3, verify the distribution is a probability distribution. To do that, we have 2 rules, that we have to check, and that is 0 has to be less than or equal to P of X less than or equal to 1. All probabilities have to be between 0 and 1, and then the sum of all the probabilities has to equal 1. So we're going to look at all of our probabilities first. Is 0.216, 0.432, 0.288, 0.064. Are they between 0 and 1? Yes. And then we want to check on our calculator. We're going to add all those up, and we're going to get a value. And I don't have that written down. So 0.216. Got a rubber band on the calculator. 0.216 plus 0.432 plus 0.288 plus 0.064, and we get a solid, there's a 1. So because they added up to 1, then our big answer is yes. We verified that that is a probability distribution. Go ahead and try it yourself 3 on page 193. Verify that it is a probability distribution. And you should see that it is. Example 4, next page. Now we're going to determine if it is a probability distribution and explain your reasoning. Do want you to do the second part, explain your reasoning. So again, we have 2 checks. First check is, are all of these between 0 and 1? And it's going to be really easy to see when they're not. So they're all between 0 and 1, so that worked. And so next check is we want to sum, we want to add up all of the P of X's. When you do that, you're going to get 1.07. That is not equal to 1, so no, this is not a probability distribution because it's not equal to 1. Number 2, we have 1/2, 1/4. What do you notice about 5/4? Well, 5/4 is bigger than 1. -1 is smaller than 0. So this is no, because it's not P of X less than equal to 1, greater than equal to 0. -1 is smaller. 5/4 is bigger than 1, so that is not a probability distribution. Go ahead and pause the video and try it yourself 4. See if you can identify a probability distribution. All right, number 1, we want to check. First, we're going to check all of our fractions. All of our fractions have a numerator that's smaller than the denominator. So yes, these are all between 0 and 1. Second thing is we want to add them up. So yes, between 0 and 1. Then we want to add up. What's the sum? Well, the sum is 1. And so therefore it meets both conditions. So yes, this is a probability distribution. Number 2, they're all between 0 and 1, so that works. But if we add up the sum of the P of X, you got 1.04. So no, because it has to equal 1. Not 1.04, not 1.01, not 0.99. Has to be exactly equal to 1. And the last thing we're talking about is how to find our mean and standard deviation for a probability distribution. In the next lesson, we're actually going to find there's a shortcut way, but for now, we're going to use this method. To find the mean of a discrete probability distribution, we're going to mu is our mean, our population mean. We're going to do this. We're going to sum up, right? The big E thing is sum, all of the X's times their probabilities. So the value of each X is multiplied by its corresponding probability, and then we're going to add them all together. That is our mean. So to find our mean, again, this is going back to our passive aggressive traits. We're going to find all of the XPXs. So we're just going to multiply the numbers. So 1 times 0.16 is 0.16. 2 times 0.22 is 0.44. 3 times 0.028 is 0.84. 4 times 0.20, that is 0.80. And 5 times 0.14 is 0.70. We're going to add all of those together, and we get 2.94. Therefore, our mean is the sum, add up, all of the X's times the P of X's. These are all of the X's times the P of X's. Therefore, our mean is 2.94. So our average of the personality traits is really close to 3. And that kind of makes sense because 0.28 was the biggest percentage in our frequency distribution. Next, try it yourself 5 on page 194. Find the mean of the probability distribution you constructed in try it yourself 2. So I don't have those table. On my smartboard, I actually copied the table, and I didn't do that here. So look back in your notes. That's where we had the sales per day and the numbers per day. And so we had our sales. And so I'll sketch this down. This was 0, 1, 2, 3, 4, 5, 6, 7. And then we had our probability, which we found by dividing by 100. And that was 0.16, 0.19, 0.15, 0.21, 0.09, 0.10. 0.08, and 0.02. And then we want to find our x's times our p of x's. So we're just going to multiply. 0 times 0.16 is 0. 1 times 0.19 is 0.19. 2 times 0.15 is 0.30. 3 times 0.21 is 0.63. 4 times 0.09 is 0.36. 5 times 0.10 is 0.50. 6 times 0.08 is 0.48. And 7 times 0.02 is 0.14. Our mean then is the sum of the x's times the p of x's. And we're going to add up all of those values, our xp of x's, add all these together. And when we do that, we should get 2.6. So there's our mean. The next thing we're going to look at is our variance and standard deviation. Our variance then is going to be the sum of the differentials, the x minus mu squared added together times their p of x. We're going to add all those together. We'll do one example of those. And then the standard deviation would be the square root of the variance. So here's our example for finding the variance and standard deviation. So we already knew the mu. We did that in the previous problem. Again, we're back to our passive regressive traits. Our average we know is 2.94. So the first thing we're going to find is our deviations. To find our deviations, we're going to do x minus mu. Mu is 2.94. And so that's going to be negative. We're going to just do the subtraction. So it's got to be x has to go first. So 0.16 minus 2.94. That's negative 1.94. X 0.22 minus 2.94 is negative 0.94. X 2.8 minus 2.94. I'm doing the wrong numbers. This would be 1, sorry, I was doing the p of x's, I should have been doing the x's. This is 1 minus 2.94, that's negative 1.94. 2 minus 2.94 is negative 0.94. 3 minus 2.94 is 0.06. 4 minus 2.94 is 1.06. 5 times minus 2.94 is 2.06. So there's our deviations. And then we're going to square our deviations. So x minus our mu squared. Then we're going to take our x minus mu squared and multiply it by p of x. And for these, it's actually probably easier to actually just work your way across as you go. And so I'll show you a couple of what I'm doing, and then I'll come in and fill in the charts. So we had our x minus mu, and so that was our 1 minus 2.94. So that's our negative 1.94. We're going to square that. So I'm just going to do on my calculator squared. That has to be a positive, right? Every time we square a number, it's got to be positive, because if it was negative, it'd have to cancel. So that gives me the 3.76. Then I'm going to multiply by its probability. So while I have that on the screen, I'm going to go ahead and multiply by 0.16. And that gives me 0.60. And we're going to do that for our next 4 rows. And so negative 0.94 squared is 0.88. I'm going to multiply that by 0.22 is 0.19. You'll actually see these will get smaller, then they'll get bigger. Why? Because the farther away from the mean, the bigger the deviation is. So this is number 3. We're going to square 0.06. That's 0.004. We're going to multiply that by 0.28. That's 0.001. We're going to square 1.06. That's 1.12. We're going to multiply by 0.20. That's 0.225. Same thing with 2.06. We're going to square that. It's 4.24. And multiply that by 0.14 is 0.59. Now, the last thing we're going to do to find our sum of squares is our sum of squares is equal to the sum of our x minus mu's, our deviation squared, times p of x. So now we just want to add all those together. And so we're going to add all those together. And that's our sigma squared. Sum of squares is our sigma squared. And we're going to add all these together, and you should get 1.61 or thereabouts. Therefore, to get sigma, we're just going to square root the sum of squares on your calculator, and that is 1.27. Now, I know that's a lot of steps, but it's the same thing we did back in chapter 2, but now we're applying it to discrete probability distributions. I'm gonna let you try yourself 6 on your own. I don't have that one worked out. The last thing we're going to talk about is expected value. This is an application of discrete probability distributions. Expected value of a discrete random variable is equal to the mean of the random variable. Remember, the mean is just equal to the sum of all the x's times the x's. This is determined, used to determine what we call a fair game or expected value. So expected value is what you expect to happen each time. And then what happens is if our expected value is 0, then it's actually called a fair game. And I'll explain that as we go through these. So at a raffle, 1,500 tickets are sold at $2 each for 4 prizes of $500, $250, $150, and $75. You buy 1 ticket. What is expected value that you gain? So what we're going to do is we're going to take basically the profit. So the sum of x of px means we're going to add up the profit times the probability. Profit times probability. So you're paying $2 for a ticket, and we're going to take profit times probability. So let's say you win a prize. So first prize was $500. What's your profit? You don't actually win $500 because you paid $2 for a ticket. So your first place profit is actually $4.98, $2 less than 500. What's the probability that you win that? Well, there was 1 that won out of 1,500 tickets. We're going to add that to what's second place. Second place is $250, but the profit is $248. And we're going to multiply that by the chance you win, which is 1 out of 1,500. Plus, next is $150, but that's really $148 when we take out the $2 times 1 out of 1,500. Plus, last one is 75, but you really win 73 times 1 out of 1,500. What's left? Well, there's a bunch of people that didn't win. And so if 4 people won, that means there were 1,446 people that didn't win out of 1,500. And what they win, well, they didn't win anything. They lost $2. So it's going to be -2 if you didn't win, because that's your profit. You lost $2 times the probability that you didn't win. We're going to do all of that on our calculator, being very careful. And our value is our expected value. So E of X is our expected value. That's -1.35. Now, what does that mean? Well, that means that on average, each ticket that is sold is not profiting or losing $1.35. Now, why is that a good thing? Well, most organizations that do a raffle like that, it's a fundraiser. And so this $1.35 is actually how much is going to the organization that is participating in the fundraiser. That's called expected value. Go ahead and pause the video and try yourself 7. And we'll come back and see if we got the right answer. So now we have 2,000 tickets sold at $5 each for 5 prizes of this monetary amount. You buy 1 ticket. What is expected value of your gain? So first price is 2,000, but you lost 5 on the sale. So $19.95 times 1 out of 2,000 plus $5 from 1,000 is $9.95 times 1 out of 2,000 plus $4.95 times 1 out of 2,000 plus where are we at? $2.45 times 1 out of 2,000 plus 95 times 1 out of 2,000. So if 5 people win, how many didn't win? Well, there's 1,995 that didn't win out of 2,000, and they all lost $5. So -5 times 1,995 out of 2,000. That gives us our expected value. E of X is 3.08. So again, this is like a fundraiser. Each ticket is generating $3.08 for the $5 of tickets that sold. This is actually could be applied to actual games. And if this value is actually 0, then it's considered a fair game. For example, if you would flip a coin each time, the number of heads, number of tails, this would equal 0, and therefore it should be a fair game. All right, in 4.1, we talked about the difference between discrete and continuous variables. We constructed our distribution. We found our formulas for mean, variance, and standard deviation. We talked about expected value. Your homework for section 4.1 is page 197, and we're doing problems 1 through 12 and 14 through 38 even. Have a good day, Maroons.